is MLDCAT, MLDCAT-AP, an application profile to catalog machine learning models under the AI Act. For this, we have Emidio Stani from PwC in Belgium and Weyts, a technology consultant also with PwC Belgium.
And I will do again the introduction. So, this is, we will present now, as I mentioned earlier, so this is the other part of the work we do, interrelation with AI and interoperability. So it's about interoperability for AI. So, it's based on the DCAT-AP, so I guess also, who knows DCAT-AP in the room? Okay, so a big majority. So it's based on DCAT-AP. DCAT-AP, and this is an important message as well, is that what we have been developing in SEMIC is always to create these data models to ensure their conformance with the legislation. So DCAT-AP was born mostly, it was adapted for the Open Data Directive, and we also on the European Strategy for Data, we have the high-value data set implementing regulation. So we create extensions for HVD, for example, and for specific data space according to the legislation, also to the needs of the community. So it's a way to catalog metadata, and since there was the AI Act and there were also a number of I would say, open LLMs, we think it was necessary also to describe large language models, a way so to extend DCAT-AP to collect metadata. And so the choice was to use MLDCAT-AP because large language models are becoming also part of the data space, so we know that there is a need, I would say, a description of what this large language model are. And here you see a bit of the interrelation between DCAT-AP. So we have a full ecosystem. Of course, we also follow, we update when W3C updates DCAT, it's based on DCAT. And after we create a number of extensions, countries create their own extension, and we have the one that we also control, so like GeoDCAT-AP, MLDCAT-AP are an example. There are also other extensions out there that are their own owners. And the idea is to have all this extension working compatible with the main DCAT-AP, so to have a common base to describe in all domains and to improve the discoverability. And with that, I will let the floor to Ine for the need.
Yes, thank you, Josh. So when we are talking about data exchange in machine learning, we have on the one hand the providers of the machine learning models, and on the other hand the users. For the providers, we have requirements of transparency, and they also want to publish it through a platform, for example. The users, on the other hand, they find it important that the machine learning models are findable, reproducible, the quality is high, and therefore they also use the same platforms to find the machine learning models. We also have the AI Act, and it entered into force in August this year, which is also a big influence for MLDCAT-AP. We need to make sure that the providers and the users both have the guarantees that what they want and what they need can be provided. We have been working on MLDCAT-AP for 2 years already, 2.5 years. It started with the initial release, MLDCAT-AP 1.00, which was in collaboration with, after a pilot with OpenML, and we reused concepts from DCAT-AP 2.1.01. Then we have MLDCAT-AP version 2.00, where we added some analysis and features from Hugging Face, Kaggle, and different repositories of machine learning models, and we started to align with DCAT-AP 3.00. So, for example, we included paper, algorithm, risk, etc. Then we had an update, a minor release of 2.1.0, where we updated the model to align with the AI Act annexes 11 to 13. So we included a bunch of new different classes, such as benchmark, computer infrastructure, hardware, environmental impact, and more. Then recently, on the 30th of September 2025, we released the latest version, MLDCAT-AP 3.00, which is aligned with DCAT-AP 3.0.1. So the 3 of MLDCAT-AP aligns with the DCAT-AP version 3. So the major releases are the same. And in this release, we also added elements to align with the AI code of practice, for example, modality. So in summary, we have different sources for the latest version of machine learning DCAT-AP. We have the legal aspect, which is represented by the AI Act. We have the policy aspect, which is represented by the AI code of practice. And then we have various data models that we also take into account, such as DCAT-AP, and other data models such as LPWC, DPV, etc. When we look into a little bit more detail, for example, the AI Act, here on the left-hand side you can see a screenshot from the AI Act, and on the right-hand side you can see a screenshot from the specification of MLDCAT-AP. So you can really see that it maps different aspects from the annexes of the AI Act to the application profile that we have developed. So for example, you see that there are acceptable use policies applicable, that it's a requirement from the AI Act, and we have the elements to model it as well. And on the far right of the table, you can see a column ref, which has a reference to the sections in the AI Code of Practice or the AI Act that mention the requirement of these properties. The same goes for the AI Code of Practice, which is a little bit more structured. They also have definitions for most of the elements. And here we see again on the left-hand side a screenshot from the AI Code of Practice, and on the right-hand side we see how it maps. So for example, geographical coverage is something that we reused from DCAT-AP, but is required from the AI Code of Practice. So we really try to reuse where possible, while also taking into account the different elements from the AI Code of Practice. Same thing for DCAT-AP, we reuse wherever we can, and we also have some requirements, especially in the class dataset, which mainly comes from DCAT-AP. We try to have as much information as possible and as needed in MLDCAT-AP as well. My colleague Emidio will now enter into a little bit more detail on MLDCAT-AP.
Thank you, Ine. Indeed, while we have a requirement from the AI Act or AI Code of Practice, the idea from MLDCAT-AP is to encompass the process of model building and evaluation, so the machine learning model, how they are built. And the story on the process starts with the data collection, data preparation. So I have my own data set on which I want to create my machine learning model. So I would like to train on that. So I pass from the phase of data collection to the data preparation. And in order to create my machine learning model, I need to choose an algorithm. And there are many algorithms out of there. When you want to indeed choose, you can name them like a random forest, etc. Then you would like to train your model and choosing different strategies to train your model. Evaluating the model against certain, for example, benchmark that you do, and generate the end prediction. This step, let's say the focus on MLDCAT so far starts from the data preparation till the generation and prediction. And we see it here in the next slide here, how it happens in practice. In MLDCAT 3.0, you see that it's a big model. I'm not going to name all the classes, but the big part is in the middle, that are all the concepts that are coming from DCAT-AP, including, for example, Catalogue, dataset, and especially distribution. Then, in the case of data preparation, I need to have also ensure a certain quality of the data. That is also mentioned from the AI Act, where the data has to be a certain quality. And as I said, when I need to choose also the algorithm on which creating my machine learning model. So it's represented in the bottom of this such a diagram. And then when training the model, so I'm going to create a model, I need to describe it with different properties. Together with also maybe the computer infrastructure, the hardware or the library that I use. And those are indeed foreseen already from the AI Act and the AI Code of Practice, in order for data model provider to describe and to be transparent as much as possible. In addition, as I said, I need to evaluate the model. I can evaluate it through benchmark myself when I create my machine learning model. I can estimate certain risks that are given maybe from the data set that on which I trained on. And at the end, I generate a prediction. In this case, also, I have the data set that is output of machine learning model. So it works as an input and again as output of the process. So while the overall, let's say, diagram might be so complex and, let's say, big, you see here in reality that the mandatory properties of the model are really small. You see in this diagram just 3 classes, let's say the machine learning model class with 4 properties only when it's been created, a name or a version of it. But then as mandatory, so far we have the dataset on which it's been trained, because a model to exist must be trained on a certain dataset. And then you have a collection date or description or title. And then especially the file on which the machine model, let's say, exists. So sometimes you can even split the model in multiple files. So for such file, you want to characterize the format, let's say, identifier for it, a title, etc. This, while this could be, let's say, abstract from the specification itself, we would like to provide tools for implementers of MLDCAT-AP. So far, we provide a validator, an MLDCAT-AP validator, which allows to validate RDF graph data against the MLDCAT-AP. And we have now version 2.10 and version 3.0.0, so it's already possible to validate against it. And then thanks to this, to the ITB service of the Commission, it's possible to do it via web interface, but also via API, with a REST API. An example of using the validator itself comes from the pilot that we've done with the AI for EOSC, concluded recently during the summer. AI for EOSC as a platform that, as Ina was mentioned before, has also presents for data model machine learning model providers a catalog of their machine learning models, structured in a certain way through web interface, but they have also an API. So we have done a pilot with them to improve the semantic interoperability of such API. So it's possible to export the metadata of these machine learning models in MLDCAT-AP. So then they can be even more connected between each other. So they can be even, let's say their definition is, you can find, for example, machine learning models that are trained on the same libraries. While before it was not really possible, because then they are disconnected itself. So we are talking about linked data per se. So that is indeed a way, indeed, a pilot that allows us also to improve our specification. And indeed, we envisage also to do other type of pilots. Indeed, as a next step, I invite you indeed to contact us for pilot opportunities, if interested, through the Digit SEMIC team mailing list, or to provide additional feedback on GitHub. All our specifications on SEMIC are on GitHub, and so we use all the platform for providing issues, or even join the MLDCAT-AP community on the SEMIC Support Center. Thanks a lot for listening.